So it's lesson 12 today. It's our last class of our semester, and actually this is our last class together. I'm not teaching you guys anything in semester 4. So what are we doing today for our last class? Well, let's have a look. So I'm going to talk about the final exam. I will go over assignment 2, part 3, which is due on Monday. And we'll do a fairly simple lesson on integrating web API with our beer store. We'll look at installing the Postman tool so we can use it to test the API. And then we're also going to look at a tool called the Open API and Swagger, which is going to auto-generate documentation for us. So let's start with our exam. So here is everyone probably has seen this link. I will put it in the chat. So here's the computer science exams for this semester. So our exam is scheduled for 2 weeks from today, on the 15th. So we have nothing next week, but note the time. The time is not at 2 o'clock when our regular class is scheduled from 2 to 5. So our class is at 11 a.m. So the exam starts at 11. You have until 2 p.m. to submit the exam. Okay? Now on the syllabus, I had said the final exam was going to be worth 25%. I've bumped that very slightly to 27%. The reason is I had planned to have 10 quizzes worth 2% each, but we only have 9 quizzes. So I'm going to add that extra 2% to the exam. So the exam will open at 11. You do have to submit by 2 o'clock on the 15th, and you do need to sign into the WebEx room so that you can use the chat. That way I can give everybody the instructions all at once, and you should stay signed into the WebEx session in case you have any tech problems or want to ask me any questions during the exam. The format of the exam. The format is a fully practical exam. So you're going to have 3 hours. I will probably provide you with a starter project. So you're not going to have to build a new project from scratch. I know that everybody in the class already knows how to do that. So I'm going to give you a project. It will likely already be connected to a central database. And then I'm going to give you a list of requirements of what you need to do in that application. And the exam is going to be randomized, so everybody is going to have a different set of similar but not exactly the same requirements. And obviously the test is open book. You can use any resources on D2L. You can use your own coursework. And at the end of 3 hours, you'll just submit to GitHub. I'm also going to steal one of Jarrett's ideas, and I'm going to ensure that you actually are committing regularly. So you're going to have to make commits to GitHub every 20 or 30 minutes through the exam in order to receive a mark. So that shows me your process, shows me that you are actively working, and I can see your progress through the exam. You won't have to use Azure at all for the exam. I will set up the database, and you do not need to deploy your site to Azure. So for those of you who your Azure accounts have expired, that is not going to cause any difficulty. And in fact, what I've decided to do, rather than build a brand new application or series of brand new applications, what we're going to do for the exam is you're actually going to work on the beer store. So I'm going to add a whole bunch of additional requirements. Some are simple, some are more complicated, about additional things that we could and maybe would have done with our beer store if we had a longer semester and we had more time. So we have a functioning application, but there are lots of little things, some little, some big things that we could do to improve it. So you're already going to be working within a context that you're familiar. I'm not giving you something totally different and new to do on the exam. There will be nothing to do with the payment. We are not going to touch that. So I'm not going to ask you to do anything else in terms of Stripe payment. You will not be evaluated on that part. I will provide the starter project. So if your beer store is not in good shape, it doesn't matter. You should be working off the starter project that I provide rather than your own. Are there any questions from anybody about the final exam? The only other thing that I will ask, as I ask any class, if you have any sort of accommodation for the exam, then please connect with me, maybe after class, to let me know so we can figure that out. The time to be working out those arrangements is not like on the exam day. So if you have any sort of accommodation, if that applies to you, then please reach out to me as soon as possible so that we can discuss it and come up with a suitable arrangement. Okay, so there's our exam. I do want to go over assignment 2, part 3. It's worth 5%. It's due next Monday. It's not a very big assignment. Won't take you very long. You're mostly just scaffolding. So for next week, you will have the assignment and you will have a quiz. So the assignment's on D2L, so it's due on Monday. Just resubmit your GitHub and Azure links, and once you submit it, please turn your Azure site back on if you still have credits so that I can run it. If you don't have any Azure credits left, not the end of the world, but it's going to mean I can get your grade back much faster. So for part 3, you are going to build a simple API. So in your existing project, you'll create a new subfolder called API, and you'll use the scaffolding tools to create one scaffolded controller that's mapped to one of the tables in your database. So we're going to do this today with our beer storing class. You'll commit to GitHub. You may only need one commit. That's fine. Publish to Azure if you can. And I will give you up to 2 bonus marks if you show me some independent learning with Web API. If you do this, make sure that you outline it in your README file so I know what the feature is that you have decided to tackle. So 8 marks for the API and a couple marks for version control and 1 for deploying to the server. It's only out of 11. Shouldn't take longer than maybe an hour to do part 3. So it's still due, even though we don't have class next week, this is still going to be due next Monday at 5 o'clock. And everything you need to do for this, we're going to go over in class starting in a couple minutes. Are there any questions about assignment 2, part 3? I have seen lots of submissions roll in for assignment 2, part 2. I should be able to get those marked, get your unit tests marked by the time you submit part 3 next week. I will do my best to get part 2 back to you. All right, so let's jump into Web API. Whoops. So there's an item here in D2L in lesson 12. It says define the following terms in everyday language. So if you just open up that item, D2L is weird. I've updated it in here, but it doesn't show in the folder above. Just go back here. So here's what I want you to do by way of introduction. There's 5 terms here. Now, this is not a breakout activity. You can do this on your own. So depending on which group you are in, so same group as last week, I want you to take a minute, and if you're in group one, I want you to come up with an everyday definition for what an API is, like a non-technical definition that the average person could understand in everyday language. So if you're in group one, here's the term API. Group two, your term is REST. Group three, your term is PUT. Group four, your term is URI. And group five, HTTP status code 400. So I'm only going to give you about 3 minutes for this. Use your best search engine skills and come up with a easy to understand definition. So whatever group you're in, that's the term. And I'll check back with you at 2:15. We'll hear what some of your definitions are. So see what you can find out, and we'll compare notes at 2:15. All right, so our 3 minutes are up. So I'd like to hear either in the chat or using your mic from anybody in group one. How would you define in everyday language what is an API? Okay. Justine, that's a great definition. I'm going to put that right in here. Right? So it's about letting two applications talk to one another. Pretty simple. Okay. Anybody else from group one have any other definition, or anything you think we should add to this that would be helpful? Okay. Yeah, that's good, Aiden. That's true. And yeah, external meaning it's not just working inside the application, but going outside some way, somehow. That's useful too. Anybody else from group one have anything else we should add to this? Okay, thank you, Justine and Aiden. How about group two? I've assigned you the term REST, probably less familiar than the term API. What does REST mean? So most modern APIs use REST. What does that mean? Okay, yep, Nick, that's true. Thank you. And so what is representational state transfer? So you're right, it's a way of communicating with HTTP, but what specifically does this mean? Maybe someone else from group 2 can add to what Nick's contributed. Thank you, Nick. Okay, well, we'll come back to REST. If you're in group 2, I may call on you directly. Okay, thank you, Alex. Okay. So Alex, you in group 1? 3. Okay. Not exactly for put. I would say that's, Alex, what you've posted is true. That probably applies to an API as a whole. I'm actually going to add it to our first definition, right? It's a pattern that can change how systems interact. Okay. For REST. Okay. True. Okay. Thanks, Alex. What about group 3? What is put? We're going to use put today. What does it mean? You got it. Thanks, Alex. So if we're doing some sort of update in an API, the method we're calling is going to use put. So far, the only HTTP methods we've ever used are get and post, and that's going to change today. We're going to start using the put method as well for doing an update. And group 4, what's a URI? I mean, we touched on it a little bit when we were working with the Google API. What does URI stand for and what does it mean? All right. Yep, that's right, Adam. So it's an identifier for a specific resource. And what does it actually stand for? What's the acronym? Yep. Thanks, Adam. It's Uniform Resource Locator. Okay, so it's a path to a specific resource. What's the difference between a URI and a URL? Actually, it's not quite it's a uniform resource indicator. So what's the difference, URI and URL? They're related, but they're not exactly the same. There's an important distinction between the two of these. Can anybody find the difference? That's a great answer. Thank you, Stella. So a URI is an indicator of a resource, but a URL includes the protocol, so it's something like HTTP or FTP. So all URLs are examples of URIs, but not all URIs are URLs. So for example, in a mobile application, the path to a file or an image stored on the device, that path is a URI on the device, but it's not a URL. It's not web-based. It doesn't use HTTP or FTP. So a URL is a subset of URI. So we use URIs in terms of pointing to resources within an API. And group 5, the HTTP status code 400, what does that mean? Thank you, Stella and Oasis. So it's a bad request. Yep, thanks, Nick. Put these things in here. So an example of this might be, for example, we have an API method that requires a parameter, and a user calls that method but doesn't pass in the required parameter value. That should generate a 400. So it would throw an error, but it's not an error because the code is buggy. It's an error because what the user is asking for, they haven't followed the requirements in order to make that request. Okay. All right, so we're going to use all of these terms today when we're looking at building an API. Thank you for those answers. So I've updated the item on D2L. So we've worked with APIs in this class, but we've worked with other developers' APIs. Okay, and thanks, Nick. I will add that to our description of REST. So REST APIs, they use HTTP requests for performing create, read, update, and delete. So we do read with get, we do updates with put, we do create with post, and delete, obviously, with delete. Thank you for that update, Nick. So we've been working with the Google API, we work with the Microsoft Login API, and we've worked with the Stripe Payment Gateway API. So in each case, our beer store application, we've been the client. We are integrating third-party functionality by calling and hooking into APIs that are API services created by other providers. What we want to look at today is we want to create our own API. So we want to allow another application to access some of the data in our application. So I'll show you just a quick use case of what this might look like, when we might use an API that was built in .NET Core. So this is a mobile application project. It was actually built at the college by programmer and web students here. was created as a research project, and it's now published in the Play Store and it's in use. So the front end of this app is all JavaScript, HTML, and CSS. It's using the Ionic framework with AngularJS. But the app doesn't talk to any backend database directly. The database is using SQL Server. So the app actually talks to an API that was built in .NET Core. So we've got all the controllers here that has all our get, post, put, and delete methods. So we can see methods in here for getting a list, for updating, we use put. There's a post method for adding new records, and delete methods as well. So our idea here is our mobile app does not talk directly to the database. It talks to the API instead. And then we also have a separate web portal that also uses the same API. So the API allows us to have one backend code base for both a web front end and a mobile front end. We don't have to build two separate backend components to do this. So I've put up a link here. This is building a simple tutorial with .NET Core. Actually, there's a couple of them, a couple links here. So we're going to add an API into our existing beer store. Now, before we do, the one other thing we want to do here is we need this tool. If you can click on this link to the Postman REST client, I want you to go ahead and open up and download this application. It's not very large, it's free. You can sign in, I believe, with your Lakehead account. So I want you to download and install Postman because our API has no front end. So the idea is Postman is a tool that's going to allow us to submit API requests and interpret the responses. And we can make get, put, post, and delete requests. So go ahead and download Postman. And we can kind of let that run in the background as we set up our API. I'm going to get my beer store running. So my store's up and running. So we're not going to actually touch the front end of the site today. Just going to open my sample project as well. So once your beer store is up and running, let's go to our Solution Explorer. And inside our controllers folder, I'm going to add a new folder. I'll call the folder API. So I'm going to make a new controller in here, but it's not a web controller. It's simply a JSON service. We want to be able to send and receive JSON. So we'll create two controllers in here. First, I'm going to right-click my API controller. I'll click Add Controller, sorry, my API folder. The first time, I'm going to pick an empty controller. But it's not an MVC empty controller, it's an API controller instead. And I'll click Add. And Visual Studio just wants to call this values controller.cs. That's fine. I'm just going to leave the name. This is just kind of a testing file. So I'll just leave the default name as values controller and click add. And here's what we get. So there's a declaration here that says this is an API controller. Actually, hang on. You may want to use a different template. Bear with me for a second. I'm just going to delete this for a minute. I'm just going to try this one for a minute. Yeah, you know what? We're going to try that instead. So sorry, I'll delete it and delete your values controller. I don't want an empty one. I want to pick the other option. Delete your controller will recreate it. So I'll right click my API folder. I'll choose add controller. This time I want this option. I meant to pick this one. API controller with read write actions. So this isn't connecting to a database. And I'll call it values controller. Hopefully third time's a charm. So here's what we get. The root, so this is the path, all the URLs are going to start with API/values. And you'll notice the methods we have here. There's 5 methods. Get with no parameters that returns a list of strings. And it uses the REST method HTTP GET. We have 2 GET methods. One with no parameters and a second one that accepts an ID parameter and returns, rather than a list of strings, it returns just a single string. We've also got a post method, a put method for doing an update. So that's going to accept an ID parameter, as well as a method body. And lastly, we've got an HTTP delete that does exactly what it says. So we can try this API out. And this is where we're going to use Postman. So you're going to open up Postman. So I want to try our get methods first. So our first method at API/values, it should return a JSON object that says value 1 and value 2. We'll try it out. So I'm going to grab the URL from my homepage, just my localhost URL. When Postman first opened, you may have a splash screen here, so just click Create New Request. Or you may even just be able to create a new tab. Sorry, we don't have to create a new request. You can just create a new tab. So it looks like this. It defaults to the get method, and it wants us to put in our request URL. So I'm going to paste in the URL to my homepage and then add API/values, and I'm going to send my request. And if I pull this up, it shows me at the bottom I got back an array of strings that said value 1 and value 2. And I also get an HTTP status code of 200, which is the standard response for a successful GET request. So in a GET request, the response will contain an entity corresponding to the request. In POST, the response will contain an entity describing or containing the result of an action. So not using the database, it's just returning hard-coded list. So it's calling this version of our API. Right? It's giving us a list when we go to API/values with no parameters. If we put a numeric value on the end, we're going to get a single string that comes back. So let's try that. If I now put issue a GET request, but I put a number on, my result should be different because it's going to call the second GET method. So I'll hit send, and notice now we get back just a single value. So same URL, just with or without the parameters, we get a different result. We can now also try a POST method. So it accepts a string called value. And this is where we can also, let's see how this works. So I'm going to try this out instead. Shrink Postman down. Actually, I'll run it. So it's going to be the same endpoint, API/values, right? There's the path. But this time I want to change the method from get to post. So in this dropdown, I'm going to change the method to post. And then we can provide a body. So I'll click body. And I think I'll submit my request. I'll click raw. And I can add a JSON format here. And it's looking for a key called value. So I've changed my method from get to post. I'm providing a value here. And I'll try my post request. And we got back, that's interesting, unsupported media type. Oh, because I picked text, I have to change this little drop down here from text to JSON. I'm submitting, normally we use JSON. We'll try again. That's interesting. What if we try it this way? I'll try submitting it through a form. No. So notice we get the 400 error. I'm not exactly sure why it's not taking our string value, but we get a bad request when it can't interpret our post request. We could also try a delete request. I'll send a delete. and we get a 200 response. Calls our delete method. What will happen if we try to delete without an ID value? What type of status, HTTP status, do you think we should get back? If you submit a delete request with no ID in the URL. Right, so our method is not allowed. But if we provide a parameter, now our request runs. So Alex is correct. Okay, so it gives us these. I'm a little confused why our post didn't work. I'm just going to try it one more time. Especially if I use my form. I'm not entirely sure why it's giving us our unsupported media type. Odd. I won't worry too much about it for now. So there's kind of like our dummy, our test controller. Now we're going to scaffold another controller. And this is basically all you have to do for your assignment. So I'm going to right-click my API folder. I'm going to add a controller. But this time I want the last option. I want an API controller with actions using Entity Framework. What is this going to give us? An API controller with REST actions to create, read, update, delete, and list entries using an Entity Framework data context. So this is going to use our application DB context and scaffold out functional get methods, a create, an edit, and a delete method. So pick this last option and click add. Our model, let's pick our product model. The data context class should default to our application DB context, and our controller name is products controller. Yes, we already have a products controller, but that's in the root folder of controllers. This is going inside controllers and API. So we'll scaffold that out. I do promise to have you done early today. So what we're doing now, this is basically 5 super easy % for assignment 2 part 3. You'll create the API subfolder. You'll create one API controller with Entity Framework. So we get a controller that looks similar to the web controller we have. The difference is the root, it runs under API. Again, we've seen this before. We've got our constructor with dependency injection. It accepts an instance of our database connection. And there are 5 methods here. So we have a get, which returns an asynchronously a list of products. If we call the exact same URL, but we append a number on the end, it gets a single product. So this is kind of like the details method in our web controller. We have a put that also takes an ID parameter, and it takes a product object. It says if we don't have an ID, return a 400 error. If we do have an ID, update that product and commit those changes to the database. and it returns a no content. That's a 204 response. So that's successful, but nothing's coming back. There's no data attached. We've got a post method that takes a product object, adds it to our products DB set, saves the changes, and then it returns a 201 status, which in HTTP means a new resource was created. And not only does it give us the 201 status, it also returns the new object, including the new ID. And then lastly, we have delete that also takes an ID parameter. So we can try out these methods using Postman. So I'm going to go back to Postman. I'll change my request method back to get. And now I'm going to load my site /APIs/products. Just restart my server. So our API now fetches all the products in the beer store. So for example, if we wanted to now build a mobile app, rather than connecting to our database directly, our mobile app could simply call on our API to show our products. Right? So I get a JSON representation with a 200 status code, response okay. If I wanted to look up just one product and test that API using Postman, how would I do it? So this gives us everything in the products table. What could we do to retrieve just a single product? You got it. Stella and Alex, right. We could add in any existing ID and run a new GET request. And now we get just that one product. What response should I get with product ID 77? What status should we get here? Right. So in this case, correct, that resource, product 77, can't be found. So 404 is an appropriate HTTP response code. So when we call get, it tries to find the product. If it's null, it returns a 404. Otherwise, it returns a 200 OK, as well as the data that matches the request. So the URLs are really important. The format of the URL dictates what method we're running along with the method name. And we're primarily interested in get, post, put, and delete. There are some other HTTP methods we're not really too concerned about though. So the idea is that these methods, they actually describe what we're doing with the data. We're reading, we're creating, we're updating, or we're removing. Okay, it's 2:52. Does anybody have any questions so far about our API that we've scaffolded. Haven't touched it, haven't made any changes. We just let Visual Studio create it as it is, which is all I'm asking you to do in the assignment. So we won't be too long with the rest of today's lesson, but there is a little more we do need to do. We do need to try out post, put, and delete. And I also want to show you a tool that you can use to generate documentation for your API. Because it's not enough to just build an API. We have to document it so that other developers of other systems know how to integrate with it. Just like we read and used the documentation on Stripe. So there's some neat tools we can plug into Visual Studio that will automatically document our API for us. So we shouldn't be any longer than 20 or 30 more minutes in this lesson, but we've been at it for 55 minutes. We're going to take a pause here and we'll come back at 3:05 and do those things. We should wrap up by 3:30 at the latest today. Okay, let's take a 10-minute break. Go stretch our legs.